Okay, so hey viewer, we will be solving the problem for the printing all the subsequences of the given array. Let me recall, we have created this particular recursive function for this particular 1 to 3 array. And what are the subsequences? Subsequence can be any contiguous or non-contiguous portion of the array which is in the order. Yes, which is in the order. So the array element should be in the order for the subsequence. Make sense? And empty subsequence can also be a subsequence for any given array. So this is what the code we have derived. Now what we have to do, we have to simply go and write run out. Okay, so you can take the picture of this particular code. I'll be making it a dry run. Okay, so what was the code that we have? Let's see here. So I know for sure f of 0 comma data structure. Now my data structure will be empty. My data structure can be anything, list, vector, array. Okay, and this will be my caller function, means whatever I'm calling from the main function, this will be my caller function. Now this function goes into the memory, and now this function will going to look like something like this, which is my 0 index and my data structure. Now what I'll be doing, I'll be asking, hey, are you somehow equal to n? What is n? N will be the 3 here. So are you equal to 3? No, I am not. So I'll be calling you for next particular guy, and I'll be adding this particular value of 0 into me. So what is the value of 0? So if you have array something like 1 to 3, and this will be 0 1 2. So for 0 you have something like as 1. For 1 it will be 2, and for 2 it will be a 3. Obviously array elements. So I'll be going for the next particular index, which is a 1, and now into your data structure, assume it like a container. I'll be storing this particular value for the 0, which will be something like as 1 here. Then I'll be again moving. Okay, what is the recursion? You'll have to move to the left, ultimate left call, and then you'll be coming back in that way. Now here I'll be coming for this particular 1 comma 1 function call. Hey 1, are you somehow equal to 3? I am not. So I'll be calling this particular for the next particular index, and then I'll be adding myself into that. What is the array of 1? It will be something like as 2 here. Okay, then this 2 comes into the memory. 2 is not again equal to 3. Then I'll be calling it for 3, and then I'll be adding something like 1 2 3. Makes sense. Now 3 comes into the memory. 3 will be like, hey, I'm equal to 3, I'm equal to index. Okay, you are equal to index. So what I'll be doing, so this is my output window, and what I'll be doing, I'll be printing this 1 2 3 onto the output. Makes sense? Okay, and from here I'll be return back, and then I'll be coming down to here. Now when I come down to here, what I have to remove, I have to remove the previously added value, which is 3. So I'll be removing 3, and now my data structure will again become 1 2. Then I have to move for the next particular index with something like as 1 2. When I reaching the third index, whatever the data structure that I'm coming is a subsequence for me, and I'll going to print it. So it will be something like 1 2. Then I'll be coming back, then I'll be coming back, then I'll be removing this particular 2 because I'm coming back. Then I'll be moving for this particular 2 here for with this particular 1, and I'll not be taking any value. Now for this particular 2 I have 1. Now I'll be moving for the left for the third guy, and then I have to take this particular 2, which is, what is the 2? Array of 2 will be something like as 3, so it will be something like as a 1 3. Makes sense? And for, because it is a index equal to 3 position, what I have to do, I'll have to print this particular data structure. Then I'll again return back. I have to remove this particular 3. I'll be moving to here something like as 3 with 1 value. Then I'll be printing this particular 1. Okay, and then I'll be moving back, and I'll be removing this particular 1 added value, because when I'll be moving back, means a non-tech process, I'll be removing the previously added value. Now this was for taking the 0th index. Now what if I'm not taking the 0th index element? Then I'll be simply moving to 1, and the data structure will again empty. Makes sense? Now here I'll trying to move for something like as 2, and then I'll have to take the 1 index ka guy, which is a 2 here. Then I'll try to move for 3, and then I'll try to take 2 index ka guy, like 2 3. Now here I'm for 2 3, so I'll be printing this 2 comma 3 guy as a subsequence. I'll be moving back, I'll be removing this particular 3, I'll be coming here, I'll be moving for 3, I have this particular 2, I'll be printing this 2. Okay, then I'll again come back, remove this particular 2, I'll be moving here for the 2 index. Now I have empty subset. Makes sense? Then I'll be trying to move for this particular f of 3. Okay, I'll try to move for this particular f of 3 with taking the 2 guy. What is the 2 guy? 2 guy is a 3, and then I have this particular 3. I'll be printing it, I'll be moving back, I'll be removing this particular 3, I'll be move for this particular 3 with the empty subset, and this empty subset for the index 3 is what I'll be going to do. I'll be going to print. Okay, this is what I'll be printing here. I'll be move back, I'll be removing everything from the data structure, and I'll be coming to my original state with the empty data structure. And this is how I'm going to print this all the subsequences for a given array. So how many subsequences? 1 2 3 4 5 6 7 8. Exact 8 subsequences, including this particular empty one. So for the array of the size something like as 3, exactly the size of the array is 3, you got 8 subsequences. That means 2 to the power n subsequences is what you will be getting. Okay, so that's the rule for forming the subsequences. I hope you understand this. If you understood, like, okay, thank you.